Two-way analysis of variance by Bartolata Joshua and Kabuhat Jan L.E.R. Introduction. A key to statistical tests in research fields including biology, economics, and psychology, analysis or variance or ANOVA is very useful for analyzing datasets. It allows comparisons to be made between three or more groups of data. The two-way ANOVA compares the mean differences between groups that have been split on two different independent variables called factors. The primary purpose of a two-way ANOVA is to understand if there is an interaction between the two independent variables on the dependent variable. The interaction term in a two-way ANOVA informs you whether the effect of one of your independent variables on the dependent variable is the same for all values of your independent variable, and vice versa. For example, the effect of gender or male or female on test anxiety influenced by educational level, undergraduate or postgraduate. Additionally, if a statistically significant interaction is found, you need to determine whether there are any simple main effects, and if there are, what these effects are. We discuss this later in our guide. When you choose to analyze your data using two-way ANOVA, part of the process involves checking to make sure the data you want to analyze can be analyzed using a two-way ANOVA. You need to do this because it is only appropriate to use a two-way ANOVA if your data passes the assumptions that are required for a two-way ANOVA to give you a valid result. Two-way ANOVA is a statistical test in research fields. As I have said, it can be used in different fields including biology, economics, and psychology. It allows comparisons to be made between three or more groups of data. It is like one-way ANOVA. It is a hypothesis-based test. However, in the two-way ANOVA, each sample is defined in two ways and resultingly put into two categorical groups. The two-way ANOVA therefore examines the effect of two independent variables. The two factors affect each other to influence the continuous variable.
So in this design of experiment, we are required to make an assembly language application or file that produces the outputs of a two-way ANOVA. In this slide, it is shown that there are eight boxes that contains different informations that you will input, and this program utilizes two-way ANOVA algorithms and or formulas to solve statistical problems. This table accepts the sample values that are inputted and as well as the label of the set values. By clicking on the click here button, the field can be edited, and when done, enter the button when it's pressed. So this is only a sample of the these are the sample values that can be shown. This is the ANOVA table when the values are completely recorded in the table. As you can see, you can evaluate the different parts of the two-way ANOVA. For example, the degree of freedom, the sum of squares, the mean squares, the interaction, the error, and the total. This is also the graph on which it will be the result on the inputted values on this program. By pressing the enter button, the graph will be shown. Pressing the escape button will let the program to go back to menu screen.
I will demonstrate now how to use the program. This is the menu screen. It has buttons start, about, and close. Start. This is the table. In here, you can click the boxes to edit the fields. So for this example, we will use a performance test. The performance of each individual based on their age. Enter 5 values. Press enter to compute the values. There, the row means, the column means, the sum of each column and the averages. Press space to show the ANOVA table. The program computes for the specific values for the ANOVA table. Then, by pressing enter, the ANOVA graph will be shown. Pressing escape will let the program go back to the menu screen. So this is the about the program. It shows the info about the program. Pressing escape again will let the program go back to the menu screen. The close button closes the program back to the DOS box. This is the part of the code where it prompts the user for input on the table where you can edit the fields. These are the codes for the white space or the white field boxes. Get the mouse click info, 0 for right click and 1 for left click. So these are for the columns and rows of the box. These are the bounds. Bounds for each box. So here for this part of the code, still for the input. So here it checks the input for possible error or if the user did not input any value. So here, the part of the code where the program computes for the sum for each column and row. This for the average. The column means column 1, 2, and 3, and the row means row 1. This adds all the integer, stores the integer part, the fractions. So for row 2, the same same from row 1. And this display for each column and row, the value is computed by the program.
In regards to the ANOVA table that was shown before, these are the design or the codes used to make the colors appear. In this case, you will call the variables that are inputted in the table. For the SS row computation, these are the codes used. As you can see, there's an add and move and XOR code command. This repeats on the other rows to compute for the sum of squares, which is n row means minus average row means. This is also for the computation of the sum of squares in a column. So you can see it repeats itself for the sum of squares. Also, the inputted values are being called and been added and been moved. So I see there's also an error computation and for when the user does not input any values on the table. This is also the code for the total computation of the sum of squares. This is also for the mean square and the freedom calculation. And here's the graph. As you can see, different colors were used to make the program usable and easy to use. Codes for y coordinates and x coordinates. So in this design of experiment, we have learned that two-way ANOVA is a test that allows one to make comparisons between the means of three or more groups of data, where two independent variables are considered. It compares the effect of multiple groups of two independent variables on a dependent variable and on each other, where each variable should have multiple samples. Two-way ANOVA is designed to access the interrelationship of two independent variables on a dependent variable. It meets all three principles of design of experiments, which are replication, randomization, and local. Thank you for listening.